Say it loud. Loud and clear.
Hello everybody, my name is Professor Suborno Bari, and hello, my name is Professor Suborno Bari, and today we're going to be looking at some more physics. Today is just mainly filled up with practice problems, but we'll get to the start of the do now right now. Okay, so as we wait for our assistant to come back. Okay. So now we're going to start the problem. I'm not sure how I'm going to do this, but
It doesn't look. What kind of nonsense is that?
so a rotor takes 5 minutes to accelerate from rest to 20,000 RPM. So find its angular acceleration. I'm not sure if you could hear me for that little bit, but okay. So we're going to start approaching this problem by converting 5 minutes to 300 seconds. Now, 20,000 rotations per minute. We also
Can you
have...
speak louder, Professor?
Oh no. Oh my god, we have over 100 students here, by the way.
Wow.
Almost 120. Anyways, if you want me to speak louder, I will. 20,000 divided by 60. Oh, weird. RPS, because we want to convert this from revolutions per minute to revolutions per second. So that's going to be 1,000 over 3 RPS. Now, we're going to write the equation for omega, the angular velocity, because we know that angular acceleration is delta omega over delta t. So omega has two equations. We're going to be using 2 pi f, the less common one. So that will be 2 times 1,000 over 3 equals to 2,000 over 3 times 2,000 pi over 3. Okay, we're back to normal from that annoying noise. We have almost 150 students, by the way, which is great for one lecture. So, angular acceleration is delta W over delta T, and we know that W is this mess, 2,000 pi over 3, which I'm going to, so 2 over 3 is 0.67. So that means 2,000 over 3 would be 10,000 times, no, 1,000 times that, which is going to be this. And that is going to be we're just going to approximate this using numbers. Does somebody have a calculator over here?
What do you need to approximate, Professor?
2,000 pi over 3.
Well, what is 2,000 over 3? First approximate that.
666.67?
Yeah, so just write that times pi.
Yeah.
So that's it. You can just box that as your final answer.
No, we're trying to find the acceleration, the angular acceleration.
So, okay, divide 666.7 pi divided by how many seconds? 300 seconds. So just simplify then. That's pretty easy.
Wait.
So you know what?
6.6.
That's the same thing as 2000 pi over 900.
Wait, hold up.
So what's 2000 pi over 900?
That's equal to 2 over 9 pi,
Wow, okay.
I guess.
Are you sure? Wait. It's 2000 pi over 900.
Wait, no.
So it should be 20 over 9 pi.
Oh, yeah.
Let's get your facts straight, Professor.
So, wait.
Just because I'm illiterate doesn't mean I'll accept your math mistakes.
Okay. Well, it seems like this must be 6.67 over 3.
Wow, we still have 150 students.
Ugh.
That's pretty crazy.
This is weird.
Please, Professor, is that it? Do we have anything else?
Yes, in fact. We really do have a lot more for today. So, I need something to erase.
No, why don't you have a lot of white space. Why don't you use that for your lesson?
Okay. Well, then next clip will have to be even smaller than that. So, we have to use our space to our advantage.
Yeah. Professor, did you know the louder you speak, the more subscribers we get?
Oh my god. He's right.
Start
We're
shouting.
going to... So, for the lesson, let's take the same rotor we have.
The same what?
The rotor.
Oh, rotor.
I mean, the do now. And we're going to find how many revolutions it did while it was accelerating for 5 minutes. First, we're going to, we know that this is 2000 over 3 pi. It's going to be very beautiful exact number. That's why I'm keeping the fraction here.
I see.
So 2000 over 3 pi. And we found no. So now we want to find x, and we know that x is going to be half alpha t squared. And this is not illegal physics, by the way. Don't think it's illegal physics. The 172 of you.
Now there are 172 students?
Yeah.
Now 180, Professor.
Oh my gosh. Times alpha is going to be 20 pi over 9. Leaving us with 10 pi over 9 already. Times t squared.
Don't block what you write, remember.
What is... Okay. 300 squared is going to be 90,000. Meaning that this will just give me 10,000. Meaning I can combine the zeros. This is very confusing, but I think this should be the answer for x. But we want to find how many revolutions we did.
Is that in the right SI units?
We have to divide it by 2 pi 7. So that will give us exactly...
Wow. We have so many students.
Wait.
Why don't you say thank you for watching, everyone?
Thank you for watching, everybody. And this gives us exactly 50,000.
What are the units? You're just gonna not write units?
This is just revolutions, the number of revolutions. So we only have 132 students now, which is kind of sad.
Wow. So that means you lost 50 students
Sad.
in a matter of seconds? That's okay.
50,000 revolutions, which for scientific notation is 5 times 10 raised to the 4
Yep.
revolutions.
I can confirm that.
Now,
I
with
can
the
flip.
exit, I came up with my very own...
Can you not
special
block what you
problem.
write? Always blocking what you write.
Now, let's say you have a music disc playing.
Music what?
You have your favorite music disc playing. And say that it's rotating at 15 RPM or 15 RPM or 0.25 RPS. Now, say that the radius of this certain disk is 0.03 meters. Now I'm going
Professor, do you know what it means to write big?
Now find omega.
That's a sarcastic question. Oh, omega is change in theta over change in time. Wait. Can I try it? So omega is change in theta over change in time.
But is theta given?
Wait, what are we even given?
There you have your favorite music that's playing. It's rotating at 15 RPM or 0.25 RPS, and it has a radius of 0.03 meters. Give omega in, what is the units?
It's radians per second, Professor.
Okay.
That's the units for W, also known as angular velocity. So let me try to solve it, okay?
Okay.
So velocity is usually equal to distance over time. So let's see, what's the distance it travels and how much time does it take? So it travels the distance of 0.03 times 2 times pi. So write that.
What? No.
2 pi r, sir.
But that's the circumference of a circle.
Divided by the time it takes. Now we know the period is, let's see, I can read, Professor. So it does 15 revolutions per minute or 0.25 revolutions per second. I'm interested in seconds, not minutes. So let's see, 0.25 revolutions per second, but I want the period, which is the number of seconds per one cycle. So that means it takes one revolution every 4 seconds. That means the denominator, also known as the period, will be 4 seconds. So if we go ahead and divide all of that crap, I'm going to get 0.06 pi divided by 4. So let's multiply top and bottom by 100 so that I get 6 pi over 400, which simplifies to 3 pi over 200. And you can box that as your answer, 3 over 200 pi.
What? Let's see if that's gonna be the correct answer, because there's another equation.
It's the same thing. Frequency is the same as 1 over period, Professor.
Well,
let's get your facts straight this time.
So 2 pi r.
So it's gonna be 2 pi r times 0.25, but that'll give you the exact same answer as what I got, Professor.
2 pi, so 0.06.
This professor is really good. I'm glad I took him for physics.
Okay, time. Yep, that gives you the same answer. So that's exactly correct. Good job.
Thank you, Professor. Is that it?
Yep. Bye, everybody, and we're ending with exactly 1, 2, 3 viewers. Bye.